Good afternoon, everyone. Welcome to Revolution in the Data Center, which is all about bringing the cloud inside. In this session, you'll learn why you might want to do such a thing and how hyperconverged can be an enabling technology. As Amanda said, my name is Gary Little. I'm a technical director at Nutanix, and mostly I work on improving our HCI product performance, and also I help our customers architect their workloads to run more efficiently in a private cloud. So before we get on to the hows of running a cloud inside your data center, I wanted to just kind of touch on why on earth you would want to do such a thing as bring a cloud inside. Because the public cloud is useful for a great many different types of workloads, and we're certainly not proposing that all of those workloads fit inside a private data center. So for instance, classic examples are startups that are just beginning their journey. They don't want to have any kind of capital expenditure, so public cloud is a great way to get something up and running without having to buy hardware, so that fits great for startups. Even large companies whose workloads are very elastic. Of course, the classic example being a retailer who has a probably 10x increase in traffic at the end of November in the US, which is the Thanksgiving holiday, Black Friday. So public cloud is great because I can rent capacity just for that period of time, which is much better than owning all of that hardware. But for mature organizations whose workloads are much more consistent, who have a lot of workloads and infrastructure running right now, there can be some very real benefits to architecting both current and future data center designs in a way that brings some of the public cloud benefits into the private data center. So this is the subject that we're here to discuss today. And specifically, by creating a cloud infrastructure in my own data center, we can bring some really nice benefits, particularly the main one here is the agility, so reducing the time to implementation for projects, and that's one of the benefits that even traditional companies find from public cloud is that it's much easier to spin up new workloads, and by using cloud infrastructure ideas inside the data center, we can bring that agility inside our own data center without having to rent space in a public cloud. Another benefit that we can bring is what I call reduced toil, where toil is really just the work that we ask human beings to do to essentially just attend to the machines. So that's not intellectually kind of challenging work, or we're not really bringing benefit to any kind of business benefit. We're just looking after the machines. I'm thinking of doing patching, upgrades, those kinds of things. And of course, software and infrastructure in a cloud, whether public or private, still needs to be upgraded. But using some of these cloud ideas that we'll touch on in a few minutes, we can actually reduce the amount of time we spend on doing those activities, even though, of course, those activities still need to be carried out. And lastly, the key thing we're trying to improve by bringing cloud inside is to gain better resilience overall. If you think about any time the cloud goes down, so anytime AWS have an outage, it is literally headline news. And on the one hand, nobody wants to be in the headline news for outage, but on the other hand, the steady state of a cloud is so reliable that when it's not there, it becomes news. And so we want to bring that same expectation of resilience to our own data centers that we expect from the private cloud. And we want to give all of these benefits to existing applications that are in themselves not in any sense cloud native. So I'm talking about the same applications that we run in today's infrastructure. We want to be able to continue to run those on this kind of cloud infrastructure that I'm proposing. And we can bring the benefits of cloud to existing applications by making the infrastructure on which these traditional applications run appear to be a cloud. Because it turns out that just having the infrastructure be cloudy kind of brings some of the properties of cloud and cloud native applications to traditional applications. So what I'm talking about here is an infrastructure as a service. So not really talking so much about the platform as a service or cloud native applications. I'm talking about infrastructure as a service that allows me to think of my entire data center as what I call it a single address space. So if you're familiar with any kind of programming, the single address space just means that I have one place in which I can put all my virtual machines, and I can think of that single address space as the one place where I'm going to provision my work. So if you've ever used a public cloud kind of portal, when you go and create some new machines in there, all you're really saying is, okay, what are the properties of my machines? I may specify an availability zone or a location, so which country, east, west, central, and so on. But I don't have to tell the public cloud which host I'm going to provision these virtual machines onto, and I don't tell it which storage it's connected to. I just know that my virtual machine is going to run somewhere, and as long as the cloud has the capacity to run it, I don't have to tell it anything else. So this is what we're trying to get to, is basically a flat compute plane that allows me just to provision work into what I'm going to make my cloud, and I can just treat it as one entity. Now, anytime that we start talking about bringing the cloud inside, or we talk about making existing architectures like a cloud, many people are going to object to that and say it's essentially not possible, because when we think of the public cloud and we think of what our own experience of that, what typically we end up thinking about is the services that those clouds provide. So of course, Google provides search and it has an index of the web. Amazon has an enormous storefront and many other services too. Facebook obviously is known for social network, and Microsoft, well known in a kind of cloud space for its applications as a service, Office 365, and so on and so forth. But those are the services that are offered by the clouds. If we dig deeper though, if we dig into the kind of the core of these clouds and how they're built, particularly if we start to look at the infrastructure behind those services, we start to find a lot of commonality in how those services are built. And we find what I'm calling the design principles of cloud. And if we look at those principles, it becomes clear that what works for the public cloud could also work for a private cloud, because there's nothing special about Amazon or Google or Facebook, Baidu, Alibaba in terms of these principles. In fact, these principles that sometimes we call web scale are in reality just principles of distributed systems.